Hi everybody, welcome to this video that's going to hopefully teach you a little bit about how I animate in Desmos, which might be a little different than videos that other people have put out there, but I hope that it might be valuable as you are trying to create activities and things like that for your students and maybe want to spruce it up a little bit. So without further ado, let's go ahead and let's jump into it. And by the end of the video, we should be creating an activity together so that way you can see this process in action. So the first thing that I typically do is I actually start my building in an open graph, not an activity builder, just in an open graph, because Desmos restricts how many people can work on an activity at once, and so this just keeps you in your own little space and you can work on it without interfering with other people who might be actually in the activity, and you get to keep it so that way in the future you can maybe branch off and like copy this format, and you'll always have this template, if you will, kind of in your folders saved in Desmos. And so anyway, we can title this whatever we want. And let's get going here. So there are three things that you kind of want to think about beforehand, before you really start. The first thing that's important is time. And time being able to flow in reaction to something that's going on in your activity. It could eventually lead to multiple actions or multiple things that are triggering time, and it can be as complicated as you really want to make it. Second thing is, what object are you going to have animated? So it could be a pencil, it could be a car, it could be clouds. Lots of different things will have different layers and stuff like that, and you'll see how they interact. And then the third thing is, what paths are these objects going to be taking? And this is why I love animating in Desmos so much, is because that is the math side of things. And my brain just works, it has the art and the math kind of all mixed together. And so I love doing this stuff. And so it could be a simple function or it could be complex things like piecewise functions. It doesn't even have to be a function. There are tricks to get around that as well. So the first thing that I like to do in Desmos actually is set up a folder, and there's a nice little shortcut. If you don't know, you can type the word folder and it will just create that for you. But folders make it easy to group things together. You can open and close them, and it just kind of keeps your workspace a little cleaner. You don't have all that math stuff floating around and getting lost. And an important thing about folders and just how Desmos prioritizes things. The folders that are on the top with low numbers, so like 1 versus 2 versus 3, those are actually towards the back of your scene and your situation. So it's almost like reverse of Photoshop. If you're familiar with Photoshop or editing video, usually the things that are on the bottom are on the bottom. They're furthest back in the distance, but Desmos is just upside down. And so the reason that's important, usually this first folder, I typically create a background folder, and that is for things that kind of are static or that just need to be furthest back to set the scene. So with the resources that I kind of have in Photoshop or wherever, I've made a little bit of a gradient, and we'll go ahead and resize this to 20 and 20. That's usually I work by 10, 10, 10s, and 10s on each axis. And so yeah, that's about it for my background. Eventually I think I might put some clouds in here, but for the moment I'm going to leave that just the way it is. The next folder that I like to create, so let's close that up for you. So if I make a folder, this is going to be the mathy stuff. Real technical. I like to keep that as fun as possible. And so the first mathy thing that you're going to need is that idea of time. And I don't know if this is formal or informal, but I really like to spell out the word time because it keeps that locked in my head about what is going on. So you'll notice I got the subscript there. All you have to do is type the T and an underscore and then IME, and it will keep all the letters after that underscore in your subscript. So time is going to start at 0 seconds and just progress, and you'll notice it pulled up my bounds for time. So 0 seconds. And one thing you kind of have to know about Desmos and how it plays, we're creating a slider here. If you set this up with just some amount of time that it will end at, Desmos always plays this slider in 4 seconds. Okay, so obviously from 0 to 4, that's not a big deal. But if I make that 0 to 100, you'll really see that here. I'm playing it, and the button is going to slide from 0 to 100 in 4 seconds still. So time as a number is moving much faster. And so one thing that I like to do is see it in real time, to have a one-to-one sort of relationship between time in Desmos and real time that I see it on my computer. And so I'm going to go ahead and make that 20 seconds. And if you click on the animation properties over here below the play button, you have some different choices. I typically like it to repeat in one direction, so that way time just starts over and I can kind of see how the animation is going. And then if I keep this with 1 times speed, it's going to play that 20 seconds literally in 4 seconds, so like 5 times speed. And so I'm just going to pop this down to 0.2, which, if you understand kind of the math of that, that's negating the fact that Desmos always goes 4 seconds from beginning to end for your sliders. So kind of an interesting little thing here. And now you can see it is going 1 second, 2 seconds, 3 seconds, and that's in real time. So after we do time, one other thing that I like to have control over is the speed of my animation. And so speed, typically you could have 0 speed, it's not going to move. Or you could go up to like 10 times speed, 20 times speed, or whatever, but I typically make my step for that just 1. So every single spacing is 1 unit there. So there's the start of our Mathy stuff. Okay, we have to have time that flows, and we have to have a speed that it's going to move at. So the next layer of this is what path am I going to follow? And so we can name this whatever function we want. F of x is pretty standard. And we can make it linear, so y equals 2x minus 4. And we could kind of fly through the scene from the bottom, middle to the upper right. We could make this the absolute value of x, and it could kind of ping off the origin from the upper left to the top right, or kind of we could go backwards if we really wanted to. I'm going to make this a little bit more interesting. I'm going to make this sine of x, and actually I'm going to amplify that a little bit by 2. Might be good. And then I'm going to shift that down 4, let's say 5 units. And this is just going to be up and down, up and down, up and down, which is interesting. As we animate this, our object will do that up and down movement. But I also would like to maybe get a little bit of a slope in there. And so I'm just going to go ahead and add x, which is a little too steep, so I might make that 0.5x. So now we're kind of going up and down, up and down, up and down, but overall rising. So we're just adding in a part of a line. So that is the path that my object will follow. I'm probably going to put a car in here. That was my thought. And so the car is going to go from the left to the right, just how I see it in my head. So the next thing that typically I try to do, let me move all of these into the actual folder. You can tell that by the faint gray line that's there. So we need a point that is going to travel along this path. So this black line is my road. Now I need something that's actually going to move according to time. So I typically will label this, point. And if you type out point, Desmos is annoying in the fact that int stands for an integral. So there is a way to get around that. You just capitalize the n. I'll go ahead and put an equal sign there. But if you go down to the n afterwards and switch it to a lowercase, then you just get the word point. And so anyway, a point has an x value and a y value, and so right now you could lock this in just at -10, 0, and obviously we see that showing up right here on the edge of my background. But I don't really want it there. What I need to do is kind of lock it into the curve. But before I get into locking it to the height of the curve, I'm going to go ahead and show you how it moves and progresses from left to right, because that's really the most important thing. Height is easy if we know how to force our point to move from left to right. So the first thing that you could try to do is add in time. So you're starting at -10, or you're starting at -5 or -8, wherever you want to start, and you add in time to that. And once I go ahead and hit play on my time slider, it moves in real time. And so it's going to take about 20 seconds for that dot to move from the left side of the screen all the way over to the right side of the screen. And that takes a while, okay? So we don't just want to move by time, 1 second for 1 unit. we want to speed that up and have our distance covered by time and speed. So I'm going to go ahead and come back down to my point and multiply by speed as well. And so right now my speed is just 1 multiplying by 1. And so it's not going to change the fact that it's taking 20 seconds to go from the left to the right. But if I double the speed and play this, now it should only take 10 seconds total to get from the left to the right. So if I stop it here, I'm pretty close to 5 seconds, and that's halfway. So for this animation, I don't know, I might speed it up to 5 times speed. That might be okay. And don't worry right now about stopping that dot. You can see it way overshot the bounds of the picture. I don't care. There's an easy way to stop things back in the computation layer when we get there. But right now I'm traveling at 5 times speed. I start time, which will be activated by some other component, probably a button. And so my dot just kind of travels from left to right. Now that's not great because I want it to travel on the road. Right now we are off-road in it. And so the path that road is following was the function f of x, this guy, the sine function. But you'll notice everything kind of disappears because we don't want to be taking in x, we want to be taking in literally the x part of this point. And so all of this stuff, the -10 start, the adding of time times speed, goes right inside of f. And so you're taking those x values and you are riding on the road for those x values. One thing that gets kind of annoying sometimes, you can't always see your whole line of equation or code or whatever, and so you can just drag the edge of that so you can see a little bit more of your the stuff that you're typing. So right now if I go ahead and hit play, that red dot travels along the road, and it takes about, how long does it take, 4 seconds? Yeah, it takes 4 seconds to finish this whole thing, which is kind of nice. So that's the Mathy stuff. That's basically kind of what I do to start, and then everything's kind of hooked to that point and hooked to that path. Behind the scenes, that's where the math goes. So I'm going to turn this point off for the moment and close up my Mathy stuff folder. I'm going to make another folder, and this is actually going to be the character. So first thing first, if you are doing a character, it's sometimes nice to have a PNG file. Okay, you have JPEG files, you have TIFF files, you have all sorts of different types of files, but PNGs allow you to have a transparent background, which is nice if you just want a small object to be moving around your scene. So I'm going to go ahead and drag in a picture that I have of a flying car, and you'll notice it just plops it right in the center of the graph. Desmos likes to do that. The key here for getting this to animate properly is to create the center back here on this point. Okay, I'll turn it back on just for a second. And so all you have to do, you don't have to copy and paste any of this Mathy stuff. Since I named it, you want the center of the actual car image to be at point. So remember, you have to do that silly thing with the N. But once you get that in there, I'll turn that off, it will be centered once you play time right where that point was traveling, which is super cool. Alright, so that's kind of how you animate, at least that's how I animate, but we're going to get a little bit fancier, and one thing that I don't like about this is that my car seems kind of huge, so I'm going to maybe change the width and the height, and I like doing that, we'll call it size. I like doing that by just creating a slider, so 0 size, it doesn't exist, all the way up to 10. Alright, and so inside your width and your height, because I made this picture, I know that it's perfectly square, 10 by 10 there. So if I change the size, and if I can spell, it will let me change this. So right now it's 0, it disappeared. But I'm going to go ahead and slide this guy. So I think it originally was 10, now it's, we'll make it 7. So a little bit smaller, but that's something that you can do to have a little bit more dynamic control over your situation. The last thing, let me play this again. The car is just kind of going up and down and staying parallel to the ground. It would be good if we maybe coded or told it to like shift a little bit to, as it's going up, have its nose up in the air versus when it's descending to point its nose down. And you can do that with the angle actually. So fancy thing with angle, you can be in radians or degrees. That's actually something you can do up here in the graph settings. But we had this road up here. If I'm traveling up the road, I know that my slope is increasing versus if I'm at the top of a hill, my slope is 0 versus if I'm going down the hill, my slope is negative. That is the idea of a derivative, and so I'm actually going to put the derivative in here in that angle option. So f prime of x, I'm sorry for all of you people who hate the prime notation, and you'll notice nothing happened. My car has disappeared, it's been stolen, and that is because I'm not taking an x, I am taking in literally the position of that point along the road. So I'll copy that and paste it here. And right now, if I play this bad boy, you are probably getting pretty car sick if you are riding in there. New driver. So I'm going to go ahead and just stamp this down a little bit by multiplying by a small number, and that should kind of smooth things out a little bit. That doesn't look half bad. So you can kind of fiddle around with some of these values, but typically you'll want to squish it down so it's just a small little change. And sometimes those can have the biggest impact. So if you don't know, opacity just changes the transparency. 1 means it shows up 100%. If you set that to 0, whole thing disappears. So I'm actually going to play with that here in a second because right now it's just on a gray background. I'm also thinking that I should animate some clouds. So the character I'm pretty sure is done. I'll go back to the background folder and add some clouds in. Maybe. Okay, so if you click on an area and then drag something, it will go to that spot that was highlighted. So if I was down here, I would drop it down below, but I was up in my background folder. And my clouds are pretty small, so I'm just going to manually bump these up to be like, I don't know, 50 by 10 or something like that. And I want the center of this to be 20 units over, just scooched off the screen so that as I'm going to animate these clouds here in a second, as they move, they go across the screen, kind of like weather and wind. So for this, I'm going to put the opacity at 0.5, and that way you can see it's like halfway visible as opposed to being all the way visible or invisible. So right now it's just stuck at 20. What I want to do with this is I want to subtract time, and if I go ahead, usually I will keep time outside of my folders since it's kind of a big deal. But the clouds are moving kind of slow, and that's because they aren't traveling at the same speed. So you can kind of get a parallax effect if you're into that. But I'm going to go ahead and just have them move at the same rate, and so I need to multiply that by my speed. You could also double speed. You can do all sorts of really interesting things. So we'll reset that. And there goes my car, up and down, which is pretty cool. If you don't like the function being there, you can definitely turn that off. And as well, you can turn off the grid and the axis numbers and all that stuff. And so when you get to the activity builder, it's just going to look like a blank screen. Okay? Keep in mind, I know everything flies way out of the window here, but I don't care about that. It's just nice to have a preview that is in real time. If I wanted to change my function, alright, it's probably going to give me an error here because I have two of the same function. Let me name this F1. So I could change this. Maybe I want it to have a wave down and then a wave back up, and I could just do that by adding a quadratic instead. Maybe I'll do 0.5. Yeah, that looks pretty good. And so now the car will travel down, and then he'll kind of travel up. So that's interesting. All this stuff, it's just literally limited to your imagination. And now that we have this saved in Desmos, we're going to go ahead and we're going to shift over to the Activity Builder, which is where the hooking up happens. So I always create my scene, that way I can save it, and then I hook it up later, and usually it takes less time in the activity, a little bit more efficient. So the first thing that you're going to need to do is copy the URL at the top, so that's your website address, and then I just usually Google, teacher Desmos, and you're going to have to create a custom activity. If you aren't used to this, you just have to kind of follow along, but it is a new activity right up here. So I'm going to go ahead and title this Animation Practice and create my new activity. I did do a trial of this earlier, and it was my plan to share that with you so that way you can have that resource if you are trying to do this on your own. It's always nice to have an example to compare against, but for now, for the video, I'm going to go ahead and start from scratch so you can see my process here. So first thing that I put in here was a note, so click on the button below to animate your picture. And next to it, so we have some different options. If you aren't familiar with those, I would look at that, but I'm going to go ahead and put a graph next to it. And down below this text, I need to put a button. So we're going to click the button, and it's going to start the whole scene. You can do a lot of different things. You can hook up your animation to being correct or incorrect. You can just the number of possibilities with the activity builder are insane. But button is pretty easy to start with. I might get into some of the more complex situations later in later videos. But if you have still held on to that address up there, you can paste it, and Desmos will import your other graph. This is great unless you have already started something here and you try to paste in to your graph. It will delete everything else and literally just paste the stuff that was in that first graph, that outside graph. And so you need to be careful about that. You don't want to lose anything important. But since I started my graph outside of Desmos, and I usually go back and edit those things outside of Desmos, it will always be new once I copy and paste the link. Okay, so if I type something new stuff here, and then I come back later and I try to paste in an old graph, it clears that thing out. So hopefully that makes sense. And here's where the magic happens. Sometimes you're going to need to label things. You're going to need to name them. So I'm just going to say button name, and I don't know if I'll need this or not. Graph name. Notes can get names, but notes are just a little bit more static with the types of coding things that you can do with them. For this video, I'm just probably interested in the graph name and the button name, so whatever you want to call those. And the first thing, it took me forever to figure this out, because to be honest, I've only been doing Computational Layer stuff since COVID happened and we were all forced to literally jump in the deep end. And so I struggled and I looked at what other people had done, and it made zero sense. I took computer programming in high school, but nothing after that, so I was super rusty, and Desmos is just a different type of coding. But the first thing that I like to do is set the bounds that you're going to be able to see in the activity. Because otherwise, if you move that graph around, you might be viewing, or the student might be viewing, that weird area where you just happen to leave the graph. If you set the bounds of the graph, then it is going to always keep you confined there. It's kind of like the window on your calculator. So anyway, I typed in bounds. Oops, sorry, that is a colon after bounds. You have to do make bounds, and usually it will give you these nice little hints of things that you can do, and you can press enter to kind of slap that right in there. And so the bounds that you are going to be making are the x minimum, the x maximum, the y minimum, and the y maximum. And there are lots of different things you can do with that, but for this video I'm just going to go ahead and make it static. -10 to the left, -10 to the right, -10 down, and then 10 up. And so once you close that up, as long as you don't have too many parentheses, it will not give you any errors. Okay, so everything that we will be able to see, we will not be able to adjust this, is between -10 to 10s, left, right, up, down. After this, this is where the magic happens. We need time to be triggered. We need time to flow when we press that button. And so the first thing that we're going to do is we're going to create a number in the computational layer, time. Okay, so this number, I usually start in here with quotes, although if you want it, I'll give another variation on this in a second. If you do T with an underscore and then IME, that is not going to work. And this was a source of frustration for a while because in the computational layer it doesn't understand that the I and the M and the E are all together down there. In order to get subscripts that are words, multiple characters down there below, you need to put curly brackets down there. That was so frustrating. So we're creating a number that's called time. Okay, and time is going to start based on the button that we have kind of in the other component. And so you're going to say the button name, if that was button number 2 or jump button or whatever that is what you will type here, and usually it pops it up because it's something that's available. And then I press period, and these are the things that I can do using that component. Time since press, which we are going to use, the history, the last value, the press count, so if you pressed it 5 times, that could lead to some action. Or script allows you to go inside of that component and grab something from inside of that component. So if the button is doing something in there mechanically, you can pull that out, whether it's a true-false value or whether it's a number or whatever. So script is kind of component to component going inside. So we want the time since they press it. They press the button, and the time since that click is going to be the time that flows inside of my graph. Now remember, I did not really worry about where all of this stopped. All my components flipped and flew off the little window, and so this is the spot where we can chop it off, where we can end our animation. And so if you remember, it took about 4 seconds to get from one side of the window to the other side of the window, and I want to give a little extra leeway on the end so the car can like fly out of the frame. So I'm just going to say 5 seconds. The default, if you don't put anything in there, is 10. You don't have to type 10, it just defaults to 10 seconds total, but I only want it to be half the time, so 5 seconds. Now once you've done that, there are no errors. Okay, even without a number, it's 10 seconds, so it's not an error. If you don't have a parenthesis there, it's going to say, hey, I can't do that. We are basically set up at this point. All right, if I hit done, I can preview this and kind of see what happens. So I have this button over here that says click me, because I changed what words were on it. I have the instructions that I kind of put in that note. I pressed enter a bunch of times to get some spacing, and my title up at the top. Now you can see my car a little bit on the edge of the frame. Depending on where you start, if I had started at -12, then it wouldn't be seen, which is sometimes what you want, but it is there. Okay, no matter if it's in the window or out of the window, it's there. So once I click it, it's following that invisible path, up and down, kind of with that U shape overall, and if I click it again, it does the same thing. So every single click restarts time, which I forgot to mention, having time in the actual graph, let me go back, the value that is here will always be overridden, okay? So if I have my time at 2.2 seconds and I say, oh, that looks great, I'm going to go out to my activity and it should be there. No, because the CL layer will always overwrite time based on this button push. Time starts at 0 because I haven't pushed that button. So something to be kind of aware of, that the CL layer has more authority sometimes when it comes to variable values. That's basically it. These are some of the foundational things that I had to kind of learn along my way, and I thought that I would share them with you. And I do this with pretty much every single Desmos animation in an activity, and as you kind of get used to it and more comfortable, you can do a lot of really cool things. And so hopefully I'll be able to post more of these videos that ramp up in style and difficulty. and hopefully they will help. I'll try to post my outline and the links to some of these resources so that you guys have those for your own projects. So good luck, and let me know if you guys have any comments or things that you want to talk about or see in the future. So take care, everyone.